Which of the following represents all solutions x, y to the system of equations shown below? This is an interesting system of equations because this is a linear equation, this first one, but the second one is nonlinear. You have a y squared right over here. Well, this one actually can be solved with substitution because 2y plus 6 needs to be equal to x, but then we also know that x is equal to y squared minus 9. So we could take y squared minus 9 and substitute it for x. So if you do that, you then can solve for y, the y of a solution to this system. So you have 2y plus 6 is equal to y squared minus 9. And so let's see, let's just get zeros on the left-hand side. So we could subtract 2y from both sides. All right, subtract 2y there. And we could subtract 6 from both sides. And then on the left-hand side, we're going to be left with 0. And on the right-hand side, you're going to have y squared minus 15 minus, actually, let me write it the other way around. Y squared, let me write the minus 2y minus 15. And now to solve for the y's that would satisfy this quadratic right over here, we could factor this quadratic expression. And let's see, the way I would do that is, first of all, can I think of two numbers whose product is negative 15, and then immediately the numbers 3 and 5, either negative 3, positive 5, or positive 3, negative 5 jump out, and whose sum is negative 2. Well, if the sum is negative, that means that the negative number has to have a larger magnitude. So it's going to be negative 5 and 3. Negative 5 and 3's product is negative 15. Their sum is negative 2. And if what I'm doing right now looks a little bit like voodoo to you, I encourage you to review factoring quadratic expressions on Khan Academy. Do a search on Khan Academy for factoring quadratic expressions. But we now know how to factor this. It's going to be 0 is equal to, we can write this as y minus 5 times y plus 3. Well, if you have the product of two things that are equal to 0, that means that you could get this to be equal to 0 by making one or both of these equal to 0. So the solutions are going to be, how do you make this one equal 0? Well, y would be equal to 5. And how do you make this one equal to 0? Well, y would be equal to negative 3. Either one of these would make one of these, y equals 5 would make this 0, which would make the entire expression 0. So this is a solution. And y equals negative 3 would make this 0, which would make this entire expression 0. So it is also a solution. Now we could go back and try to solve for the x's, or we could immediately look at our choices and say, well, any of these choices have y equals 5 and y equals negative 3 as at least the y coordinates of solutions. And these first two don't even have two choices. But this one right over here, this one, they're actually trying to trick us a little bit because, you know, we have this number 5 and negative 3. And it's like, hey, maybe this one. But this isn't y equals 5. This is x equals 5. And when x equals 5, y is equal to negative 3. That's x and that's y. The first coordinate is x. The second coordinate is y. So y equals 5 and y equals negative 3. This one is y is equal to 5 and y is equal to negative 3. So you should feel immediately pretty good about this choice right over here. This one puts the 5 and the negative 3 in for the x coordinate. That says x is equal to 5 and x is equal to negative 3. So you wouldn't, if I was under time pressure, I would just stop there and I would move on to the next question because I feel good about this choice. But if you want to go back and feel good that when y equals 5, x equals 16, and y equals negative 3, x is equal to 0, you can go back and substitute into this first equation because we have 2 times 5 plus 6 is equal to x. So when y is equal to 5, you have 10 plus 6, you have x is equal to 16. When y is equal to 5, and that's what we saw right over here. When y is 5, x is 16. And when y is negative 3, 2 times negative 3 plus 6 is equal to x. This on the left-hand side is going to be negative 6 plus 6. X is equal to 0. So when y is negative 3, x is equal to 0. So we took a little extra time to make sure that we feel good about this. But once again, under time pressure, I wouldn't have necessarily gone through to this extra length.